Hello, Armin here. Welcome to this breakdown. Today we're going to talk about several things. First of all, how do you connect Perception Neuron software to Notch software? Then how do you use a 3D mesh to emit particles and to emit clones? And then we're going to talk about how do you match your virtual set to your real world set, where you recreate the positions of, let's say, camera and the floor and the objects that you have in your viewport. So with that said, I think we're ready to start. But before we actually add any nodes or start to work in a UI, let's talk about assets that we need for this to work. First of all, we need to download Perception Neuron software. And you can do that by just heading to their homepage, which is neuronmocap.com. I'll have the link in the description down below. Just grab an Axis Neuron Pro and go for the PC download. That's exactly what I did. Their software is completely free of charge. All you have to do is follow through the steps, install, and open it up, leave it running. Right, with that done, I would like to give a shout to Mixamo. It's a very nice little page called mixamo.com, and it contains a fully rigged bone structure of 3D humanoids with a lot of animations and a lot of different meshes to choose from. So feel free to go and grab a model that you like. Alternatively, you can grab the one that I put in the asset pack. So there's a little asset pack in the description down below, and you will see that there's a couple of files there. So there's a CH36. This is literally this little fella right here in a static T position, fully rigged with bones. Again, Mixamo page does all the rigging for you if you don't want to do bone rigs yourself, which I can vouch. It's not easy to do. So this little website right here is actually a lifesaver. So we have a 3D model that we're going to use, and we have an extra file called stride1.raw. So this file we will use in the Perception Neuron software. There we go. As I open their software, I'm greeted with several tabs. Now, I don't need any of them at the moment. So what I'm going to do, I'm just going to grab this stride.1.raw file, and I'm going to drop it on a viewport in Perception Neuron. So this is a little pre-recorded animation of a very simple motion. Basically, a little walk back and forward and hands going left and right and up and down. Before we connect anything, I would like to address a couple of things in the Perception Neuron software. First of all, I would like this model to look directly at me. As you see, there are several tabs here in the bottom. The first one is model alignment. So I want this model to align and look directly at the screen. This looks much better. Okay, the animation is almost done, and I see that there's some information that I don't need. For instance, I see that there's recording of record button being pressed and then unpressed. So I think I'm going to just skip that. So I want my simulation to start somewhere here. So I can just cut the timeline from this frame and then go to the end. And I want this to end, well, let's say somewhere here. So again, I can trim the very end. Okay, let's play back. That's not too bad. This is literally all I need to run this test. Perception Neuron has a loop mode, so I'm going to set that on and I'm going to use that as a loop. Right, so I think the Perception Neuron side of things is ready. Now I have to set up a couple of things in Notch. So first of all, I need to grab that 3D model that we've spoken of. So I have already imported that to the resources, so CH36. Now, handy tip when you are getting models from Mixamo, once you drag it into the resources, you will see that you are greeted with the import tab. One important thing to remember about Mixamo files, they usually come in quite too big. So 1.0 size is actually too big for Notch. So I would always advise to set it to 0.01. Depending on what software you're using, you should always double check the scene scale and make sure that it's right for Notch. Right, so I have that asset already. It came in as an imported 3D scene. All I have to do is connect it to the root. And there it is, it's actually working. I have a static T-positioned model, and I have the whole bone structure that accompanies the file. So how do I connect a Perception Neuron with Notch? Well, Perception Neuron has a node in a Notch system, and it's called exactly that, Perception Neuron Mocap skeleton. So I'm going to drag that in, connect it to the root, and I see that there's two inputs. And we're going to talk about both of them. The first one is responsible for the connection of the 3D mesh to the perception neuron system. So the bone or the node that we're looking for in this case is the Mixamo rig 1 hips. As you see, this is the first skeletal node of the whole system. This node is exactly what we should connect to the hierarchy root input. And as we do that, there's a connection. Things happen. It doesn't look correct just yet, but we can address all these things. So now we have a connection between this imported 3D scene and the perception neuron node, as you see, is hashed out red, indicating that there's still some information needed to make this run. First of all, we're gonna rotate bind pose joints by facing directions, so it looks a little bit more correct. There we go, much better. And now we have to match the perception neuron server address and server port coming in from perception neuron. So I'm gonna head back to the perception neuron software. Right, so here if I go to File, Settings, I see that the first tab is IP. That's exactly the IP that I want to copy out and bring back to this node right here. So I'm pasting it to the Axis Neuron server address. Now the perception neuron node knows that it has to talk to the perception neuron software on this IP. Next thing we need to do, we need to go to broadcasting and make sure that BVH is enabled. And BVH has a server port. So this server port we have to bring back to Notch as well. So it's 17,000 in my case. It's great. Let's just paste that in. All right, and if I start simulation now, I see that the perception neuron is actually talking with Notch. That's pretty much all that is needed to run both of the softwares parallel. So before we move on, I want to address one specific thing. It looks like things are mirrored from the perception neuron to Notch. There is a specific button for that. It's literally called mirroring. If you press that, all of a sudden all the animations are completely aligned in the directions. There might be instances where you don't want to run both softwares in parallel. Perhaps you want to run Notch only because you're working on animations or refining animations and you literally don't need a direct connection. You just want to work with the recording. That is an option too. So if you go to the Axis Neuron Pro and go for File, Export, you can actually export a BVH file, and BVH file can be read back by Notch. So in this case, I want to change the location of the file. So I'm gonna go ahead and click on these three little dots, and I'm gonna go for the NXR assets, and I'm gonna add this animation as a BVH file there. So let's go for export, and let's give it a moment. There, it's done. So now if I come back to Notch and find that folder, I see that I have stride 1 character 00 BVH. I can drag that into the resources. It comes in as a asset, and now I can just pull it into the node graph. And in the node graph, it comes in as a mocap stream. And that's exactly the node that we can use with the second input here, mocap stream. As soon as we connect mocap stream node to the perception neuron node, we don't really need to run Axis Neuron software in the background. So if you're working just on designs, that's probably a good way to go about it. You just export the specific animation that you're after, you refine, and then when you're ready for a performance or for the direct connection, you just disconnect the node and you do a process of matching the IP address and the server port. And you're pretty much set. Right, so this is the basics of connecting perception neuron node to a Notch system and running it either in parallel with the perception neuron software or with a pre-recorded mocap stream. I think I'm going to move on to the next layer that I have here prepared, which is Neuton particles and clones. Now in this case we have the very same setup that we already discussed, but there are a couple of designs attached to it. So I'm just going to make sure to make it visible. I added a little envelope modifier to make sure that I can turn the model on and off, and I made sure that it's just white. So the designs that we are using are based on particles. So in this case, well, I think I can just disable the visibility of the model. We don't really need to see it. In this case, we have a small particle system consisting of two setups. So one is using mesh emitter as a whole, as a body, and then there's two small mesh emitters using shape 3Ds. So these two shape 3Ds are connected to the skeleton, and they are used as an emitter themselves. So if I bring back the visibility, it's probably going to make it clearer. There we go. So we have two mesh emitters. They have a little bit of curl noise, and they're using these shape 3Ds as emitter shape. Both of the shape 3Ds are connected to the hand bones. So if we just cycle through, we'll see that the hand bones are right there. So that's the right one and that's the left one. So we can connect anything and everything that we want to the mesh, anything from nulls to meshes. Any 3D object can be attached to a bone rigged 3D model. In this case, I don't really want to see the shape 3D, so I'm just going to set the visibility to 0. I just want to have them as an emitters on those specific bones. A little bit lower, we have another setup, which is using, again, a particle system as a emitter, and it has a little bit of physics. So there's a SPH effector dropping particles down, and there's a collision effector working with the shape 3D, which is in our case the floor. So all of a sudden the particles are dropping down. And these particles are rendered via clone to particle. So basically we're not rendering the points or sprites, we're rendering actual geometry by using clone to particles node. So we have particle root connected to the clone to particles, and that's pretty much the basic setup. And then we have a extra node, clone to mesh. So basically we added some 3D spheres on the actual body, so it's a little bit more readable. It's easier to see where the model is moving about. If some of these concepts of clones and particles are unfamiliar for you and you're completely new to Notch, please check the links down below. It leads to Essential course and Intermediate course. If you watch both of them, you'll be well equipped to deal and understand these systems. So with that said, we're more than familiar now with how to connect a 3D model to a perception neuron node. And we've briefly spoken about the little setup here of the particles, and a little setup right here of the clones. Now we have the basics of the connectivity and designs. I think we can talk about matching your 3D world with your actual camera footage. So for that, let's open the next file. And in this case, it's going to be Noitom XR. Right, so the first step in matching your virtual world to your real world is making sure that you have correct distances, and those distances are aligned. The easiest way to achieve that is to have some kind of a object that you can use in real world and in a virtual world in the same size, in the same shape. In my tests, I used this little drawer box right here. So I made sure to put it on the marker, and then I matched it up in the 3D world in Notch. So basically I just measured up the size of this box and I recreated the same parameters in Notch, and then I made sure to position the virtual camera and the actual camera in the same positions in 3D and in reality. So let's talk about the measurements that you need to make sure that your things align. Let's make a little sketch here. So for instance, if you have your camera, let's say it's on a nice little tripod here, you need to know the distance to your test box. So obviously the best way to do that would be to use a laser measurement tool. Now I don't really have one, so I went the old school way. I would not recommend going the old school way, it's very painful. So as mentioned, first of all, you should measure the distance from your lens to your test point. Then you have to make sure about the height of your lens, so from the floor to the center of the lens. With those two measurements, you're already in a good place. One more bit of information that you need here is the angle of the camera. So likely it's not going to be flat, it might be a little bit up or down. In my case, it was a little bit down, and the angle was more or less 5 degrees. So I've used all of that information and I added it to the Notch camera. So the height of my camera was 1.25 meter. So the distance from this marker to my camera was 3.87 meter. And the angle was 5.49. So when you have these three measurements set up, there's one more thing to take care of, and that is the field of view of your camera or of your lens. In my case, I just Googled the lens that I'm using and I just checked what would be the field of view of my lens. So let's see, I'm using Fuji 16 to 55 millimeters, and I see that in the widest it's 29 degrees. So I just ticked on use field of view Y and I typed in that specific numeric value here. And now my virtual camera is in alignment with my actual camera in my setup. Now there might be instances where aligning camera is a little bit harder. Now I was extremely lucky because I don't really have much of distortion in my camera, but if you happen to have some barrel distortions, there is a node called barrel distortion. You can compensate or overshoot any inaccuracies that you get with your lens. In my case it wasn't necessary, but I'm just pointing out that there's a little tool that might come very handy. Okay, so let's say everything is aligned now. We have a correct angle of the lens, we have the lens field of view, we have the distance from the camera to the test point, and we have the height of the camera. This is all great. How do we move forward? In this specific setup that I was working on, I have all my layers being rendered at once. So basically I went to Project, Settings, and I ticked off Layers as Separate Effects, because I wanted to have one separate layer just for the background, and I wanted to have one separate layer for the actual designs. So the background layer contains just the image 2D output and a video loader, in this case a screenshot of the room. Now obviously in the actual test I was using video in source, I was using the actual running camera. So now we're familiar with the alignment and the background, let's talk a little bit about the foreground of the actual 3D models. We have a couple of designs here, you're already familiar with them from the previous file. Let's talk about shadows. This is quite an important thing if you want to make your setup look somewhat realistic. I'm gonna make a new layer and I'm gonna call this box shadow. Right, so I'm gonna solo that in. I'm gonna make sure to copy the box. This is the very same test box that I mentioned before. And I'm gonna paste it here in a node graph. There we go, I'm gonna connect it to the root. I'm gonna make sure that it's visible. I probably should go ahead and copy out the camera too, because we want to see the same positions. Right, so let's copy the camera. I'm hitting 0 to look through that camera. And in the root node, I'm gonna make sure that we're not in a composite blend mode solid, but in a blend with alpha. All of a sudden, we see the background and the foreground together. We don't have any lighting here, so we can actually address that a little bit. I'm gonna add a voxel cone lighting. And voxel cone lighting requires bounding box. So I'm gonna add that. There we go. It's hashed out red, indicating that we need to turn on deferred rendering. I'm gonna do that. I'm gonna make sure that this bounding box is a little bit higher up. Great, so now we have a match of our 3D world and our actual world. It would be much nicer, or this would look much more convincing if we actually had some shadows dropping from this box. It would just tie things up. So in order to do that, we first of all need a light node, because voxel cone lighting does not necessarily have a specific direction. But with the regular light, we can work this out. So let's just position it a little bit higher to the side, maybe on somewhat an angle. There we go. Let's enable the shadows. And let's add some floor. So shape 3D. And let's set it to a plane, so we actually see those shadows dropping. I think I'm going to drop the brightness of the voxel cone lighting. And I'm going to address the shadows a little bit more. And now we do have shadows, but they're dropping on the plane that we just created. We don't necessarily want to see this plane. How do we subtract or retain only the shadow but not the floor? For that we have a specific node called shadow catcher. And that node is actually a material node, so we would connect it to the floor that we just made. As we do that, we get rid of the whole floor and we retain only the shadow. Now, there's still a little problem. This shadow is really harsh and it doesn't match with the rest of the setting at all. So in order to solve that, we need an extra node, and that node would be render layer. So if we put everything under the render layer, all of a sudden we have blend controls. So I'll just make it a little bit more translucent, so I'm going to reduce the alpha. In fact, if I go back now to the lighting node, I can make the shadow a little bit softer. Obviously, this shadow doesn't necessarily match with the actual lighting direction. Now, since this is a demo, I'm not going to try to align the actual lighting with the virtual lighting direction-wise. But this is more or less how you solve a shadow casting on the floor. So you have a test box, you add a floor node, you connect a shadow catcher as a material, and then to be able to control the density of that shadow, you pipe it through render layer. And you're pretty much set. Now to push this setting a little bit further and to make it a little bit more convincing, another thing that we can add here would be environment map. So if we use the same image that we have here in the background as our referral for the environment map, this could give us some better results when it comes to lighting. So I'm going to make sure that it works together with this voxel cone lighting. In fact, we could even enable some environment mapping on this test box. So now this box is a little bit closer to the actual setup that we have coming from our camera. So this lighting and shadow rig is exactly what we have in these test files right here. We have several controls, so we can switch through the whole body trails to, let's say, just the hand trails. We can make the model visible. We can make the model's shadow visible, which is as well connected to the render layer via the shadow catcher. And we have a test box. Right, and that is the basics of this setting. So we covered a couple of things. First of all, how to connect Perception Neuron Node to a Notch system. And as you've seen, that's fairly easy. Then we briefly spoke about designs. And if you want to learn more about how to create designs using clones or particles, please check out the Essential and Intermediate courses. Link in the description down below. And then we've spoken about setting up your real world to match your virtual world. And for that, we have to take some measurements. So the distance from the camera to the object, then the distance from the floor to the camera angle, and of course the field of view of your camera lens. When we cover that, we moved on to practical tips about shadows and about the general lighting. Now, obviously, this is a very simple test. This could be pushed way further and could become way more advanced. But I had a great time trying to match the virtual world with the actual world using a motion capture suit. So, thank you for watching this breakdown. See you in the next one.